Good morning, everyone. I am Erica Reed, the Program and Marketing Manager for the MSE on Coursera program, and I will be your host today. We also have a very special guest, Andrew Femright.
Good morning, good afternoon, or good evening, everyone, wherever you are. My name is Andrew Femright, Senior Instructor and Faculty Director. This is my 8th year with CU Boulder's Electrical Engineering Department after 25 years of various engineering and technical leadership roles in the industry.
All right, I will be giving a brief overview of the program, and Andrew will discuss the embedded systems, followed by a Q&A session. If you have any questions, use the Q&A feature by hovering your mouse towards the bottom of your screen, then click on the Q&A icon to type in your questions. We ask you to please refrain from using the chat function when asking your questions. All right, here's a brief overview of what is the MSE on Coursera program. A traditional on-campus graduate program requires an application process, while our program does not have an application process. No GRE, no TOEFL, no letters of recommendation. All you need to do is to prove that you can do the work, and you'll be admitted into the degree program regardless of your background. Simply complete a series of courses with a cumulative GPA of 3.0 or higher, which is a B average, and you will be admitted as a graduate student at the University of Colorado Boulder. That is what we call performance-based admission. Now, each course in a traditional program consists of 3 to 5 credit hours, while in this program, each course consists of bite-sized 0.6 to 1.2 credit hours. Now, in order to get admitted, you will need to complete a series of courses called Pathway Specialization. Each pathway specialization consists of 3 to 5 courses, which is the equivalent to a traditional 3 hours on campus. In a traditional program, there are normally 3 semesters per year. Each semester is about 16 weeks long. Our program runs 6 sessions per year. Each session is about 8 weeks long. Traditionally, students pay per semester, which can be quite expensive because you have to pay up front. Now, conversely, in this program, you pay as you go, and the tuition is $667 per credit hour. Now, what will admitted students receive? First, students in the MSE on Coursera program earn the same credentials as our on-campus students. There are no designations on the transcript, certificate, or diploma to indicate that this is an online program. The students will have fully earned accredited Master of Science in Electrical Engineering or graduate certificate. In addition, students who have been admitted into the degree program will receive a lifelong access to Handshake. This is a career-seeking tool offered by the CU Boulder Career Services. Handshake is a place where employers post jobs, as well as serving as a social network to connect with fellow alumni, including weekly virtual employer events. Finally, the CU Boulder Graduate School policies apply to admitted students. These policies include course repetition, grade replacements, academic standing, and so on and so forth. Overall, by reducing the time commitment and the number of credit hours per course, students can earn the same rigorous degree or graduate certificate without the intense 16-week commitment that traditional programs offer. These feature allows for more flexibility in regards to time and finances, which is what makes this program so attractive, especially to working professionals who may not be able to commit to a heavy course load over a 16-week period. Now, this diagram shows how the performance-based admission process works. Students need to complete a total of 30 credit hours to earn a master's degree, which includes 1 pathway specialization or more. Students have 8 years to complete the 30 credit hours with a cumulative GPA of 3.0 or higher. And on the next several slides, Andrew will be discussing the embedded system in detail.
Thanks, Erica. So let's start with the basics. What is an embedded system? While most of you may have a sense for what that is, fundamentally, an embedded system is just an intelligent electronic device dedicated to one main purpose or function. Erica, you can go ahead and build out the slide if you wouldn't mind. So intelligent means that it takes input from the environment, makes computational decisions, and performs tasks or delivers output based on those inputs. So arguably, every major market segment and their respective subcategories are teaming with embedded systems. Every one of us can name a dozen or more embedded systems around us right now, but it's almost impossible to imagine currently how many there really are in the world and how many more there will be just over the next few years. So also there are so many more that are out of sight and out of mind in the industrial segments, which we're going to talk a little more about in a few minutes. Next slide, please. So overall, electrical engineering is one of the broadest possible career paths. That's why embedded systems. To illustrate, here's some high-level semiconductor industry revenue numbers from 2019. Anybody can pull these from a simple Google search or any source you prefer, but just look at the size of the semiconductor market alone. Where are all these chips going? There's $229 billion in 2019, top 10 semiconductor producer revenue alone, over 400 billion in total just a couple of years ago. So mainly these are going into smartphones, tablets, and computers, which are not embedded systems per se because they are multifunction devices, but each of those devices is comprised of other embedded systems. And the rest of the market is all embedded systems. So there have to be, millions of jobs out there and great opportunities for all of us. As advancement in semiconductor lithography and component manufacturing steadily advance year on year, think about the prospects for creating applications or innovatively combining existing technologies across any and all these market segments. It's seemingly infinite. Are you as bullish on this prospect as I am? Let's talk about career for a moment. There are a galaxy, to me, it seems like a galaxy of technologies and careers. These are just a sampling of job titles that I think most of us see on a daily basis. But I want to talk for a moment about what matters most in any career. From my experience, regardless of discipline, geography, aptitude, what matters most is the degree to which one's talent is used and appreciated. Think about the best job you've ever had and why you liked it. Seriously. The one aspect of career always, this one aspect always tops the list in my opinion. More important than salary and benefits, company aspects, anything else. So the field of embedded systems engineering and IoT is vast, like our galaxy, and our program offers uniquely rigorous and broad course content. This is a great opportunity to competitively elevate your technical talent toward fulfilling and financially rewarding careers in more places than you've ever dreamt. Next slide, please. While there are numerous underlying categories within electrical engineering, such as computer engineering, power, signal processing, etc., the broadest application and opportunity in front of us is clearly the Internet of Things, or IoT, which is the migration of embedded systems toward connectedness. Likewise, there are subcategories upon subcategories of end markets, but at a high level, indications are that the top two IoT growth areas are automotive and transportation and industrial IoT. Regardless, the CAGR, or compound annual growth rate, there on the right-hand side, of many IoT segments is greater than 30%. Again, opportunity for all of us. Do you have a feel for what segment you might go for, where your career might lead? Next slide, please. Getting down to our program specifically, most universities offering embedded systems courses provide only slices or a portion of what I like to think of as the full spectrum. This is a bit of a metaphor. Our embedded systems engineering and IoT program began decades ago with just a few essential embedded systems courses in our legacy certificate. Then in 2015, I helped expand the program dramatically by pulling experts in from industry and aiming to cover embedded technology and design comprehensively on purpose, I like to say, rather than just using what's available within the talent of the department. So we were able to add quite a bit of talent quickly from industry and build out our full spectrum of course offerings. Next slide, please. Today, around the edge of this slide, you'll see various instructors in our program here in Boulder. We're able to expand our program rapidly by sourcing all these professionals to fill specific expertise within the spectrum of topics that we saw needing fulfilled in our program. So from our campus-based program, we prioritized 5 specific MOOC or massively open online course conversions. Those are highlighted in blue in the center, with the one in orange as work in progress right now. We prioritize these in particular because the content represents a broad sampling of our overall offering in embedded systems. These specializations also depict the uniqueness of our ESE and IoT offering, having crafted topic coverage more broadly and intentionally than most other offerings from others. And thirdly, each of these specializations do stand on their own and offer transformative knowledge. Let's take a brief look at a couple of examples. In particular, our developing industrial Internet of Things specialization goes beyond the hype of consumer IoT to emphasize a much greater space for potential embedded systems applications and growth, the industrial IoT or IIoT. So the course, as depicted in the diagram on the right-hand side, focuses on segments that for many of us on a daily basis are out of sight or out of mind, as I said earlier. Students explore the breadth of career opportunities in this space, examining emerging markets, technology trends, applications and skills required, while also providing a sampling of technologies that are pervasive throughout the IoT space and going a bit deeper on those. Next slide, please. So again, here's a diagram kind of depicting the various high-level topics in the course, which start with an inside look at specific markets, their sizes and revenue estimates, a little bit deeper on security, a little deeper technical dive, also with machine learning and big data analytics. These are currently pervasive themes across the IoT space, but as well, many other topics that are broad across these market segments are explored. Platforms, IBM Bluemix and Watson, networks, sensors, System C, etc. Next slide, please. Another example, currently under development, advanced embedded Linux development specialization preview here for you today. It's coming next year. We don't have a specific date yet. These conversions do take typically in the order of a year or more, especially with the hands-on aspects to them. But in this case, by completing a specialization, learners will be able to configure, customize, build, deploy a Linux kernel, build a customized Linux distribution, use system programming concepts to develop application software, and create a custom Linux driver. So obviously the specialization will be very rigorous and project-based, so learners will gain strong competence and gaining immediate skills for the workplace. Next slide, please. A little more detail, reading specifically from Dan Walkus's course overview. The specialization teaches you the basics of deploying production embedded devices based on the Linux operating system. Starting with concepts related to the Linux system programming, you will explore the interface between the user and kernel space, build your own embedded system from source code using cross builds and the build root project. Next, you'll learn Linux kernel development concepts, develop a custom Linux driver, and deploy an embedded device with the Yocto project. You will complete the specialization with a final project of your choice, developed and demonstrated on hardware of your choice, and implemented using agile development methodologies. So again, similar to the other 5 specializations already available in our embedded systems engineering space, clearly this content will provide very rigorous and transformative knowledge and skills. Next slide, please. So a few of the course benefits, maybe not entirely obvious, but naturally with seasoned industry professionals who built and teach these courses and the content, the materials tailored for professionals and practical applications. Learners can add skills in time for a major project or position themselves for much greater career ambitions. Next slide, please. So here are the 5 existing specializations that our ESC and IoT instructors have converted thus far, as well as the one that we've already touched on, currently under development. They primarily consist of 3 or 4 courses each, totaling 3 credit hours in each case. Next slide, please. In particular, 2 of these specializations are designated as pathway specializations, as Erica referred to earlier. Learners are required to successfully complete 1 pathway specialization for performance-based admission to our online MSEE degree. So within our ESC and IoT area, we offer 2 pathway specializations. This embedding sensors and motors pathway, as well as, next slide, please. And also our FPGA design for embedded systems pathway. Next slide, please. And finally, a few unofficial prerequisites. I think these are important to mention. Of course, just because these courses are offered in a different modality than our traditional in-person campus delivery does not mean that they are easy or without some threshold of acumen and capability needed to succeed. While an undergraduate degree is not explicitly required, some reasonable competence and minimal experience are required to be successful. Each individual must make their own assessment based on course descriptions, other information on our website, and perhaps some trial with the non-credit versions of the courses before attempting 4 credit versions. That's always an option as well. Next slide, please. Back to you, Erica.
All right, thank you so much, Andrew. In a few minutes, we will have our Q&A session, so be ready to bring up any questions you may have. Until then, we have a few more slides to go through. Now, if you're not sure you're ready for the 4 credit courses, we encourage you to enroll in the non-credit course first. Enrolling in the non-credit course will let you find out if the online format is going to work for you. The difference is that the non-credit course does not have any graded items such as final exams, so you're not going to receive any grade for it. And non-credit students may earn a course and/or specialization completion certificate from Coursera. However, that does not imply the conferral of credit from the University of Colorado Boulder, nor does the non-credit course or specialization appear on the student's transcript. And you may upgrade from non-credit to 4 credit at any time. Previously completed assignments from the non-credit course will be automatically applied to your 4 credit experience. Now, in general, additional exams will be required to earn credit for the 4 credit course, as well as successful tuition payment. The enrollment for the August session started this week, and class begins less than 2 weeks from now. Please note that you will not have access to the August session courses until class starts, which is on Monday, August 23rd at 9 a.m. And you can enroll today, but you won't get the course until class starts. If you've already started the non-credit class, feel free to upgrade to the 4 credit version, and you will not lose any of your work. After you pay tuition, brand new students are required to complete the onboarding course before they can access the lecture materials. This normally takes about a few hours to complete. The onboarding course does not affect your GPA by any means, and it is not listed on your transcript. This course provides more information about the program, how to use the Coursera platform, and the University of Colorado Boulder policies. Currently, the MSE on Coursera program cannot accept transfer credit from another program or university. You may be able to transfer the credits earned from the MSE on Coursera to another university or program at the discretion of the receiving institution. Due to the pioneering nature of this online program, we are unable to offer scholarships or financial aid at this time. We know that the cost is a consideration for everybody. Because of the online format and automation of campus processes, we have been able to greatly reduce the tuition, which is considerably less than the traditional on-campus program offered by CU Boulder today. This is a pay-as-you-go program, so the total cost can be spread out as it works best for you. And as of last month, for details on how to use your VA benefits that has been recently approved, all you need to do is check with your VA advisor and visit the website. And we currently have 3 payment options available: credit card, e-check, and Flywire. Now that sums up our overview of the MSE on Coursera, MSE's Embedded Systems webinar. Now, if you have additional questions after the webinar, please send an email to msce-mooc@colorado.edu. We are now ready for Q&A. Okay, question number 1. How long will it take to complete the program as a part-time student while working full-time? I can answer this. That totally depends on the student. We have students who graduated already, but we foresee that you have 8 years to complete the program. It really depends on how many courses you're taking at a time. It really depends.
Yeah, I'll add, Erica, that the program is designed specifically for people who need that flexibility, right? So they have the ability to scale up or down the course loads based on their professional careers or other personal issues.
That's correct. Okay, question number 2. Does this mean taking around 30 classes? Are we allowed to take more than 1 class at a time? Absolutely. We've had students who are taking 5 courses in the same 8-week session. So, and it doesn't necessarily mean you have to take 30 classes. It depends on the amount of credit hours per course. If you're taking all the courses you're taking are all 1 credit hours, then yes, 30 classes. But if some of the courses you're taking consist of 0.5, 0.6 credit hours, then you will have to take more than 30 classes. Right. Question number 3. How many courses do full-time workers, professionals typically take at once?
If I were a working professional today, looking at the coursework as I know it, I'm a little more conservative. I would probably take 1 to start and then see if I could handle that in parallel with everything else I'm doing. And then I might double up or triple up depending on how things are going in that segment of my career.
All right, question number 4. Are there any IoT specializations in the MSE on Coursera program? Are there any edge computing specializations?
I don't believe we offer any at this time. Certainly an area that we have discussed internally and may look at doing in the future, yes.
All right, question number 5. If I successfully complete the MSE on Coursera master's program, will this master's allow me to get into a more research-based degree program like a PhD in electrical engineering? So this program is specifically for working professionals. This is not intended to prepare people to get a PhD.
I would concur primarily, especially in the area of embedded systems engineering. There are certainly other specializations offered within a degree. Today, we spoke mostly about embedded systems engineering, and our courses in particular are definitely geared primarily for industrial careers.
If I complete the embedding sensors and motor specialization on Coursera, can I later apply for the MSEE degree and receive credit for those courses? If you complete the embedding sensors and motor specialization on Coursera non-credit version, if you want to make that as an MSEE degree, you will have to upgrade to the 4-credit version, pay the tuition, and take the final exams. And if you successfully completed it with a GPA of 3.0 or higher, then that is a credit for the University of Colorado Boulder.
And admission to the degree, yes.
Okay, next question, how much programming knowledge is required to be successful in the embedded systems program?
That's a difficult thing to quantify. I will start by saying that it's not a beginner's it's not, the coursework requires more than beginner level programming experience. So if you don't have any, for example, C programming experience, you would want to obtain some training or coursework elsewhere before diving into this, certainly.
Okay. Will more embedded systems classes be added in the future? Any plans to add ECN 5833, low power embedded design techniques, or ECN 5763, embedded machine vision and intelligent automation?
Great question. Both of those have been discussed. Keep in mind that it's very heavy lifting for these instructors to convert these to a MOOC format. This is more than just putting a camera in the classroom and filming their lectures, right? It's a lot of forethought and planning and how the projects will be designed for this particular modality and fitting them into Coursera's format, et cetera. So those two particular topics definitely have been discussed with the instructors as possible conversions. They're both, as most of our embedded courses are, very heavy project-based, hands-on, which requires, forethought on what hardware platforms would be available to learners globally that fit into the coursework still, as those are always a moving target. So short answer, yes, those are possibilities, but they are not currently under development. But we do discuss what to put on the docket or the plans for conversion at nearly every meeting with my instructors in the program. So we meet probably a dozen times a year. We'll discuss those again. Thank you.
Next question. What is the minimum level of knowledge a student would need in order to successfully complete the specialization? Would all of the following be required? C language, knowledge of at least one version of assembly language, circuit theory for linear and nonlinear devices, digital circuit design and analysis?
Yeah, short answer, yes. I would say that's a very, very good foundation for beginning. Coursework is one thing, but practical experience is another, right? So having some projects under your belt, even if they're at an academic level or in a professional setting, in an internship or early career stage, those are also highly recommended to really have some practical experience going in, a baseline of embedded systems design, if you will. And again, that's very difficult to quantify. We get this question often. What you listed there were definitely reasonable sort of prerequisites, if you will, of knowledge. Again, an undergraduate degree is not required, but some requisite knowledge of lab equipment, oscilloscopes, multimeters, et cetera, standard lab equipment, programming techniques, computer architecture, basic computer architecture, microcontrollers, a sense for the breadth of components you have to choose from in designing an embedded system. These are all very difficult things to quantify, but again, each individual kind of has to make their own assessment and maybe look at other examples amongst their peers or colleagues. That's my recommendation.
Next question, are there any courses on signal integrity? Not right now.
Not with conversion to our format in the degree, not yet. Certainly very high demand. We do have a campus-based one, advanced PCB design for signal integrity, but it is not yet scheduled for conversion.
Where can I find a recording of this webinar? This will be posted on YouTube within a couple of days, and people who have registered for this webinar will be sent a link. I can see only 5 embedded courses offered online for this program. Is this correct? Does this mean that in order to complete the full degree, one would need to take many non-embedded courses? Yes, that is correct. for now. Is there a plan to add 5 more embedded systems specializations to get to the 30 credit hours for the MSc or for just embedded systems?
Well, Erica, let's clarify just a little bit. I want to look at these 5. So these 5 embedded we have a semantics issue, right? When we say courses on campus, we mean a semester-long course. When we say course in this context of the online degree, we're talking about an individual, usually a 1 credit hour entity, 0.6 to 1.2 credit hours. So these 5 embedded systems specializations in total are 3 credit hours each. So that would be half the degree, 15 credit hours right there. So yeah, the other half of the degree, if you were to take these 5, would have to be a non-embedded systems specializations within the online degree. Yes, until we convert more, which we have advanced embedded Linux development in progress, launching in 2022, for example.
Can I attend with a manufacturing systems bachelor's degree?
I would say yes, provided that you have a baseline of embedded systems experience, which I went through a little bit earlier. Again, it's difficult to quantify. Regardless of what degree or degrees you may have coming into this, I would recommend, examining the course descriptions, looking at examples within your own environment or realm, colleagues, peers, LinkedIn perhaps, or other online entities you can research to see what experience is needed to be successful for individual courses or for entire areas. Degrees are not required, but knowledge, certain basic knowledge is.
I am torn between a master's in embedded systems and power electronics. Are some of the classes for these 2 majors interchangeable? For the MSc on Coursera program, everybody gets the same title on their transcript, which is Master of Science in Electrical Engineering. There are no specializations written on it. If I began the non-credit version now and then upgraded mid-course, would I only have to take the final exam once? That depends on the course. Some courses you are required to do like peer reviews. So it really depends on the course, but for the majority of them, you only really need to take the final exam. What would you recommend for someone with a background in mechanical engineering to gain the prerequisite skills to prepare for these MSc courses?
Erica, do we have some of that included in the onboarding course?
Yes, and in fact, our course list on our website, if you click on the courses with a link, they have the syllabus, and at the very top of that syllabus will say, well, like what type of knowledge that you need in order to be successful in this course.
So I believe there are sort of knowledge prerequisites listed for most or every one of the courses within the specializations. So, review those, each and every one of those for coursework you're planning to take. Overall, again, it's a difficult thing to quantify. You might take a look at a standard undergraduate degree to see what core curriculum is offered and get a sense for what topics are included there and where your knowledge should be centered in order to be successful in those areas. It is also worth mentioning that there are no hard dependencies between the courses. There's no prerequisites. You could take the courses within a specialization in any order. It would not be recommended to take them out of order. But if you already felt you could succeed in one area, you could go straight to the final exam potentially, and then move on to the next course in that sequence, hypothetically. But in any case, the prerequisite knowledge is listed at each stage, I believe.
Is this an internationally recognized degree? I say yes. What level of math is required for MSc on Coursera? Is Calculus 1 enough, or is the whole Calculus series 1, 2, 3 required? That depends on the specialization you choose. If you choose photonics and optics, yes, a high level of math skills is needed in order for you to succeed. Okay, next question. What kind of job opportunities have you seen students take advantage of after completion of the degree? We don't have that many graduates right now, but from our first graduate is currently working with a startup, and the other graduates, I believe, is currently working full time. So we don't have that many graduates, but we will have that data later this year.
Erica, I would refer back to slide 8 too. Specifically in this area, our campus program has had hundreds of graduates. And so many of them gravitate toward these applications engineering, embedded firmware engineering roles right now. Those are very popular. But any and all variations on these, you could easily interchange embedded systems with IoT for most of these job titles. So as far as our campus-based program is concerned, yeah, we have many success stories from our graduates going to work for companies from startup size, mid-tier to Fortune 500 and so on.
Is there any chance to specialize in an area of electrical engineering, example, power electronics, and would this be reflected in the degree title? No, everybody will receive Master of Science in Electrical Engineering on their transcript with no specializations on it for MSc on Coursera program. Next question, the tuition for the non-credit version and the for-credit version are different? If yes, how much is the difference? So the for-credit version is $667 per credit hour. The non-credit version is a monthly subscription. And I'm not quite sure exactly how much it is. It depends. But from what I've seen can be about $79 a month. Good question though. Next question is coming from a non-engineering degree. Would an understanding of basic circuits, digital logic, and C programming be sufficient to be successful in the embedded program?
In very general terms, yes. I think it's similar to the previous question. So hopefully you heard the various answers we've given. So again, it's a difficult thing to quantify. Look at the course descriptions and the prerequisite knowledge required to get a better, more detailed sense of that. But in very general terms, yeah, programming in C, programming concepts, computer architecture, digital concepts, signal processing, for example, familiarity with lab equipment, et cetera. Those are some very basics that are expected to be successful. Just difficult to elaborate or quantify further in the scope of this webinar.
How much experience in C and Linux is expected for the sensor specialization? Well, if I'm looking at the sensor and sensor circuit design, which is the first course of the sensor specialization, is prior knowledge needed, fundamentals of electrical engineering and fundamentals physics and unit conversion. The next question, I am an electrician. Is this degree more focused on computer and electronics than electrical?
Definitely, yes.
How can the hands-on exercises? Apart from the laptop, what hardware do we need to practice embedded systems programming?
There are literally thousands of platforms out there. Popular ones, familiar to most, I think, are Arduino and Raspberry Pi. Those are the two that always come to mind for me that are used throughout undergraduate curriculums for various projects. The expectation, just for the sake of mentioning it, an undergraduate electrical engineer should be able to effectively design an Arduino or a Raspberry Pi at the end of their undergraduate career. So using those platforms is instructional and getting familiarity with programming concepts, but developing the hardware as well as part of what we mean by embedded systems.
Will there be any hands-on training with evaluation boards or something of that sort?
Yes, there is hardware, specific hardware platforms required for nearly every one of the embedded system specializations. So those are called out at the beginning of the course, I believe.
When will the radio specialization and other planned specializations start? I say sometime next year. We will have a list for the spring session, and that will be sent out. If a student has already taken one course over the 8 years limit, but is currently enrolled in others that are within the 8-year timeframe, what is the option for the student? Can that older course be taken again? You can retake a course again if you've been admitted to the degree program to do a grade replacement, but taking the same course to double the credit, no. And for the 8 years limit, that is a good question. We'll get back to you on that one. If you can send that same question to the MSCE-MOOC, I'm going to change the slide here. We'll be able to have answers for you. And as long as just know that you can take a new course to top up the 30 credit hours, you should be fine. Next question is, if after I hopefully graduate, the new contents were added to the master's degree, can I enroll to take them? Absolutely. One of our graduates is still taking courses. Can you talk about how this master's will help in the energy transition of the future? I can't speak for power electronics. Andrew?
Yeah, not my area per se. So I think we should defer questions in that realm to our power faculty.
Can I switch to on-campus after taking some credit hours online? Yes, however, you will have to go through the application process just like everybody else for the on-campus program. Next question is, what type of resources are available to help aid with some projects or assignments? For example, office hours, tutors, etc. There are some recommended books, and we also have course facilitators, which is basically a TA, 4 to 4 credit sessions. They do office hours, they do emails, and a lot of our students are very active on the current student Slack channel, and that's how they help each other out. Would you recommend this degree to someone who would like to change electrical engineering industries? I currently work in manufacturing, industrial automation, but I would like to work with embedded systems.
Absolutely, yes. Yeah, I guess I'll reiterate a little bit of what I mentioned in the presentation. Don't underestimate the prerequisite knowledge. So, in some cases, a little more preparation may be necessary with some other offline coursework or perhaps something available in a nearby community, but provided that you have some fundamentals in place already, dive in, see how you do. Try one of the non-credit versions, see how far you get, see how you feel when you complete it. You might be surprised at how it goes.
Is previous PSOC usage knowledge required to be successful in this program?
I'm going to assume that by PSOC, I mean, that's a Cypress Semiconductor product line, programmable system on a chip. SOC is a general term, system on chip. And the answer to the question in short is no, SOC experience is not required. In fact, the FPGA Design for Embedded Systems course provides a pretty good baseline of FPGA fundamentals and SOC introductory knowledge.
Can you please elaborate on the duration of a course and how that is different from an enrollment session? So each session is 8 weeks long. The enrollment session happens 2 weeks before the session starts, and it ends 2 weeks before the session ends. So the enrollment period is also 8 weeks, but it's 2 weeks ahead of the actual session.
Shifted by 2 weeks. Okay.
Exactly. Okay. Next question. What is the difference between ESC Professional Master's Program and the MSc on Coursera? Is there a difference in content?
Great question. So the ESC Professional Master's Program, as we refer to it on campus, is comprised of about, I think we're at 17 active courses, both core and elective courses in the program. The content on the online MSEE degree from our campus program consists of only 5 of those campus courses. We call them specializations in the online degree realm, and going on 6 next year with the introduction of the Advanced Embedded Linux Development Specialization. So a portion of the campus program has been converted to the online MSEE degree.
Please describe the graduation process with respect to completing a master's thesis. Though this doesn't prepare a student for a PhD, is this master's degree every bit as credentialed to be admitted to a PhD program?
Yes.
Next question, are the pathway specializations tougher than non-pathway specializations? How are pathway specializations determined?
I can speak to the embedded systems area. So I think these pathway specializations were determined for several reasons. One, they were among the earliest to begin the conversion, right, from our campus-based material. The material is equivalent. The learning modality is the major difference, but all of the material, the intention with these conversions is to maintain continuity one-to-one with the learning objectives that we achieve on campus. So those are all very consistent. But the priority of these two, in particular FPGA design and the embedding sensors, they were the earliest to begin conversion. They're also very pervasive technologies and appropriate for a pathway specialization in embedded systems, right? There are embedded sensors in literally every embedded system. You can't have an embedded system that doesn't take input from somewhere. It would have no way to make a decision. And FPGAs, for those of us who know, field programmable gate arrays, are essentially, you're able to implement an entire embedded system on one semiconductor device with a high degree of complexity. So those are very different technologies, but appropriate and pervasive across many market segments to introduce as pathway specializations. Are they harder than other specializations? I guess that depends on your background. They are definitely apples and oranges, but I'd say all of our specializations provide a requisite amount of challenge, even for the learned few of us. So, thank you.
I am from Peru and I have a bachelor's degree in mechatronics engineering. What would I need to be properly prepared for the embedded systems MS?
Well, regardless of where you're from, I think I'll defer to some answers that were provided earlier. I don't mean to be repetitive. It's just, again, it's a difficult thing to quantify. Review what an undergraduate curriculum looks like in terms of only its core coursework and some basic prerequisite knowledge. Every one of our courses provides what primarily was needed to be successful within those courses or specializations. Taken as a whole, though, some basic knowledge in programming, C programming, assembly language, computer architecture, lab equipment, etc. I think I've mentioned those already.
Yeah, and you can always start with the non-credit version, since it is cheaper than the 4-credit version. And there's also a 2-week free trial. So that's one way that we ask students to try out before they go in full on 4-credit. So just try that. Is a PCB design software license provided if required for a course? That depends.
Off the top of my head, I don't think it's required for any of our courses currently. If it were, a license would be provided. Right now, I'm thinking through each of these specializations, and I don't believe PCB production is required in any of those cases.
If I'm enrolled in an on-campus master's program at another university for computer science, would there be a conflict of interest if I were to also enroll in the MSc on Coursera program? Could I do both? Yes, you can do both simultaneously. However, the credits from another university and the credits from CU Boulder will not merge together. Okay, next question. Can I transfer credits from MSDS to MSCE and vice versa? Yep, you can certainly take MSCE and MSDS courses simultaneously as well. But similar to the previous question, the credits from MSDS will not count towards the MSCE degree program and vice versa. Credits for both programs will not cross over. Will more graduate certificate options be added over the next few years? I say yes, right, Andrew?
Yeah, I think that's a foregone conclusion. It may not happen overnight, but yeah, that's our goal for sure.
With regards to the FPGA courses, is VHDL or Verilog or other typically used?
I don't know specifically. I think both of those are covered, at least at a basic level in the course. You have to look at the prerequisite knowledge for the individual courses to see which one or ones may be used in each case. But I think both are touched upon, and then probably one used for delivery throughout the rest of the content.
How do you currently process course content feedback? How do you frequently revise courses based on that feedback? So we really appreciate when students point out any issues, suggestions, or even typos. This goes to the course facilitator first for assessment, and then the instructor. If revisions need to be made, we normally make it before a new session starts, while making all the necessary grade changes to the current session. It really depends. But yes, we take all the feedback into consideration.
These are all really great questions, Erica. How we doing?
So far, so good.
We have quite a few more, or?
Yep, we have a few more.
Okay.
How many students have you admitted into the degree program and how many have graduated? Well, I'm glad you asked. From the pilot launch from October 2019 to May 2021 session, we have admitted a total of 188 students and 5 have graduated. Okay. How many students are currently enrolled in the program? This current session, the June 2021 session, we have a total of 285 unique students, and 203 of them are returning students, 82 are new students. Will I still have access to the course I previously enrolled in? Well, once a session is closed, you will only have access to the ungraded items. The graded items, such as the final exam, will be locked. Next question, can I roll over my tuition payment to the next session? No, tuition payments cannot be rolled over to future sessions.
That's one reason the enrollment period is skewed by 2 weeks, right? So enrollment can't happen in the last 2 weeks of the session.
Yep, that's correct. Is it possible that if I were to begin this program, would it by chance become no longer available in a few years? I don't foresee this program to be going away anytime soon. We are growing.
Yeah, electrical engineering has been around for decades, if not a century, right? So only room for growth.
Exactly. What happens if I don't take the final exam and I'm enrolled in the course? Good question. You will receive an administrative W grade, which has no bearing on your GPA, but you don't get a refund as well. Okay. Do I get a refund for non-attendance? So there is no refund for non-attendance. The only time you get a refund is if you request it within the 14-day window or enrollment and have not accessed the final exam. If I have completed the MSCE degree, can I attend a campus graduation ceremony? Yes, you will be invited to campus for graduation. What equipment is required at home in order to successfully complete these courses? That depends.
Depends on the course. Take a look at the prerequisites, hardware, any equipment needed. In a few cases, some lab equipment is required, and many professionals do have access to that in their workplace, but otherwise, short-term rentals or acquiring some home equipment might be recommended, if not required.
Okay, last question. I'm a high schooler. Would I be able to attempt this MSc on Coursera program? Well,
Again, it depends on your knowledge level and experience, some baseline embedded systems experience for our particular area. Typically, a high school education would not be anywhere near sufficient to attempt the photonics specialization, for example, where a very high level of math is required. So I'd recommend reviewing the course prerequisites in each case and making a careful assessment, and perhaps doing some preparatory work elsewhere, hobby wise, or a local course you could take, or another online course to prepare you with basic knowledge.
all right. It is 11 o'clock a.m. and that brings us to the end of this webinar. Any additional questions or concerns, please send an email to mse-mooc@colorado.edu. Thank you everyone for coming and have a great day.
Thank you.